So why flashcard is important is because later on, when you really start to, so this is my flashcard. I didn't show you guys in week 2 because I don't want to scare you guys. So those are the name of the reactions. This is for 118B because I didn't know how to use flashcard in my 118A, and I feel like no, this is a way better method to use until 118B, and I should have used that in 118A. So that's why you see start with chapter 11. So this is only like the index or the list of contents of reactions. But in 118B there are 45. In 118A only 17. You should be happy about that. It's basically, did you still remember? Reaction is the first name. Mechanism is the third name of whatever chemistry that we are talking about. So whatever chemistry, it has a name in English, and it has a name in chemistry, which is the reaction and the mechanism. So you actually have learned one, which is the halogenation of alkanes, right? That's the first one you learn. And we should actually start to use flashcards, numbering the reactions you learn, and make flashcards from the first reaction. So later on, when you put them all together, it makes sense to you. Is that clear? So let's see, although the previous one is going to be not that hard, like 1 step, 3 steps. So you can see later on your mechanism is going to be really complex in the future. That's why I say making flashcards is important, and some of them even cannot finish in 1 page. So, what makes the things worse is all your notes is chemistry, and you cannot differentiate from your reaction mechanism and something else. So what I want you to do from now on, since we have the first mechanism learned, I'm going to do the first mechanism on a flashcard with you guys. We are going to do the first 5 along with you, and because I really don't have the flashcard for 118A, so I'm still going to make them. But later on, after the first 5 mechanisms, we're not going to use our discussion time to do it. We're just going to post it in my weekly email. Does that make sense? But the first 5 are super important, and I think that's what's going to be covered in the second midterm. So I hope you use 5 flashcards to get you guys into a good habit of learning organic chemistry. The best way to do it is to only keep the chapter, which is chapter 3. The halogenation one is chapter 3. And name. So number and the name. Please do write alkanes, because later on you're going to learn halogenation of alkanes and something else. So halogenation is, you do need to write the whole stuff. There are plenty of halogenation, reaction, and mechanism in this chapter 3, and I just want you to use one of them. This is the one I'm choosing, which is the easiest one. When you are making flashcard, make sure that you write all the products. Just like resonance structure, later on you're going to write all the products of this reaction and identify which one is major. So I hope you can do that job when you are making flashcard for that reaction. So when you are really doing that in the exam, it actually saves you some time because you have seen it before, and you think about which one is major before. It's not for resonance; it's just for mechanism. You will know what I'm talking about very soon after you start to learn chapter 6. So, and the mechanism of this one, it's just my personal habit. I like to use a different color than reaction. Like the notebook I showed you before, mechanism is the blue part. Like the notebook I showed you before, I use blue color. Yeah, question?
Why is there a radical on HCl?
Oh, it's not radicals, my bad. It's not radical. It's not. It's just, I finished. It's a period.
Okay.
I usually change a color. So for halogenation, I guess all of you guys know. So you can either follow me or you can just try to like write on flashcard and see if we write on the same thing. It's fine if you don't color it, but I like to color it. So that's when the transferring of electrons, that's just my personal habit.
So there are several points that I need to talk about in making a flashcard. Whenever you are transferring a radical, use single arrow. Whenever you are transferring a pair of long pair, using double arrows, or transferring through bonds using double arrows. So that's the #1 mistake I see in radical mechanism. Here is initiation. Propagation, you can have many choice. They're not only one, and you can have the second step of propagation if you want. You can fit in if you think it's helpful. And termination, there are actually 3 other terminations. 3 more termination. I don't have the space to put the second step of propagation here. So you can do more if you want. But I think they basically is the same thing. I know how to get the arrow to other place, and there's a radical there. So that's propagation. So initiation is how you get radicals. Propagation is you make something new, but you still have radicals around. And the radicals can react with something else and make more radicals and new stuff. Termination is you clear off all the radicals you have and make no radicals around. So that's how I think about it. So as long as I know one of them, the rest is the same. Does that make sense? So that's why I only put one of them. There's another thing that I think is really useful. It's the page of that one on the book. I'm using the 7th edition, and it's on page 106. Usually after the lecture, highlights the reaction I learned with mechanism, and then I look into the book, because he might write something wrong on the blackboard or whatever screen. There might be typos or small errors on whatever, but the textbook is basically perfect. So this is something I copied down from the textbook, and next time when you want to check, you can always go to that page. Kind of a broadcast of the first 5 we're going to learn is SN1, SN2, E1, and E2. So you can see from number 2, 3, 4, 5, SN2, SN1, E1, E2. You are not going to really touch it until chapter 6. The 3, 4, 5 are in chapter 7. But it's kind of, when you are still in chapter 4, I warn you guys already. Those are the tough parts of your second midterm. And think about when you really get into those chapters, it's almost the time for the second midterm, and you don't have time to really do exercise on them. So I want you guys to jump ahead. Hopefully don't scare you guys too much. You guys are really doing a good job in the first midterm. And then see, there are still a lot of people surviving, even without that kind of warning. So you guys should be fine. Let me talk you through the quiz for real quick. So I feel like if I talk through the quiz right after the quiz, it might be helpful. So the first one is assigning hybridization, right? So I'll just talk through them real quick. Only this one is sp2, because we didn't ask you about oxygen, so this is sp2, and 1, 2, 3 is sp3. How we count sp2 to sp3 is basically see if there's double bond or not. And then the other one, which is, I just show you the key directly, the key. Most of them is sp2. Basically, everything on benzene ring is in double bond, so they are sp2. sp3, sp3. So this is the tricky one, because last time I talked you through this one, and I emphasize this a lot. So if it's the nitrogen next to a carbonyl, is actually going to have the resonance structure, so that nitrogen is actually sp2. But what if the nitrogen is just next to something sp3? It won't donate its electrons, because sp3 is basically 4 bonded already. So there's no place for this carbon to accept any electron from nitrogen. This nitrogen is just sp3, normal one. So sp3, sp3, and this carbonyl is sp2. That's it. So hopefully you guys are doing a good job on assigning hybridization. And then drawing resonance structure, I hope it's fine, but you can check. You can draw more if you want. Oh, it's not really clear here. So there's a long pair and a minus charge. So I see a lot of students in other sections that have problems in drawing this structure. CH2CH telling me there's a double bond because this carbon is only bonded to 2 hydrogen, which is the 2 hydrogen here. And the rest of them is just following the strand. Nitrogen, hydrogen, and nitrogen usually bonded to 3. Since it's only bonded to carbon and hydrogen, it has to have a formal negative charge here. And it's transfer that. This is this nitrogen is neutral, okay? This is the major one because nitrogen is more electronegative than carbon. So if there has to be a pair of electrons somewhere, it goes to nitrogen. And this one is a little bit complex, but I would say it's still, hopefully it still makes sense to a lot of you guys. The most problem I see in the past is drawing down this one because carbon has an OH, so I think the one is actually this one. The carbon has an OH, and then it's Na, and it also has a hydrogen, so this hydrogen is here, and NH2+, NH2+. So this is what exactly this structure is talking about. And it has a resonance structure because we can, for this one, it's not nitrogen donates its lone pair to the carbon. Or if you want to draw the way back, it's basically carbon-nitrogen double bond donates its double bond into nitrogen, form the lone pair on nitrogen. So if I want to draw the way back, it's this. And then this is really similar to what we had before. So that's not something. So you have a hydroxyl group, which is going to, so there's something else. And then there are two kind of correct answers. One is this oxygen is grabbing the hydrogen, and then you transfer the bond between oxygen and hydrogen. And there's another one. I see some students write down this one. The hydroxyl group is attacking the carbonyl and then transfer the pi bonds onto the oxygen. So both are correct answers. One of the benefits of practice on resonance is even you don't know that hydroxyl group is grabbing that hydrogen. And I see students drawing this in midterm. So they don't know how to use hydroxyl group, so they just leave them there. But they do remember, oh, I learned resonance structure of this one. So when they draw this, it's going to give you something like this. It's a positive charge, right? So this also, I think we still give some pressure points for this one because it makes sense. And then when you see the positive charge here, to try to make this positive charge disappear, since I have negative charge around, and then grab the hydrogen, transfer the bond to the oxygen, and make that positive charge disappear. So it's the same thing because when you are drawing like the normal way, what you get is this. And when you are drawing this way, what you finally get, let me just erase whatever, if the hydrogen is disappeared, this positive charge is disappeared. It's just changed the other way. So carbonyl is pointing up or carbonyl is pointing down. It's still the same thing. So that's one of the kind of the mechanism that you are going to use in the future. It's actually acid-base mechanism, which I think is too simple. So I didn't really put them in my 17. And I didn't realize that he asked a question. I thought he's going to ask a question in mechanism, but I didn't thought it's this one. So that's kind of, well, okay, he will. In next midterm, he definitely is going to put a mechanism question in that, and you are responsible to drawing all the arrow correct. So how good you are in drawing resonance structure is going to directly affect how good you are in drawing mechanisms. So that's why I emphasize those a lot. Okay, let's talk about nomenclature finally. Okay, do you know why this one is printed out? Doesn't like the previous one that I hand draw myself. It's because I don't like this page. So you can see whenever I don't like that page, I type them out. When I really like something, I draw them by my hand. and I just highlight them already. The pink one is the prefix, which is the number notation. And whatever the functional group, which is, for this one, is a known name. And whatever the functional group, which has to be ended with. And there's a table, which has a C table. It's the second worksheet that, second notes I pass around on the front page. There is a list of functional groups that you should be responsible before final. But for your first midterm, which you have already got, basically it's just alkane, because you only know alkane. Before the second midterm, it's only add to what you have learned. So for functional group, you just need to choose the one that has the highest rank, and then use that as base chain. Whatever else, use as substitute. Those are their names. I think this table is really handy. And for numbers, because like me, when I was taking a discussion for this one, I have no idea why you guys know those names. Butane, how do you know it's 4? So it really confused me. So I put this table here in case someone else is like me. If you really don't know where does 4 come from, the but come from, it comes from this table. And then you're responsible for the name. That's it. And then when you really start to name a compound, you follow LLA rules. That's the most handy one, I think. So basically just find the longest chain and find the lowest position number for all the subs. So that's become a question, because I know some you might heard or learn from other videos that they say you start from the end that's it's nearest to your functional group. It is the case for most. If you start from the end, it's going to give you a lower number, but it's not always the case, especially when you have a really complex molecule. So always check. You can number from left to right. You can also number it from right to left. And then you have several steps, and then you have different numbers. You add them up, and then choose the lowest one. So that's what I always do. And then, alphabet forwarder, just pay attention. Your prefix is not counted. Like if you have methane, methyl group, and then you have two methyl group is going to be dimethyl. So that dimethyl, so dimethyl, this D is not counted. Just pay attention to that. Yeah. So that's nomenclature. So if we follow the longest, our LLA rules, what LLA rules say is first find the longest chain. So our longest chain on this one is, and then the rest of them are just, so you number your family chain, which is the longest chain you have. Let's do 2 color, so it makes sense to you guys when I'm talking about. And then to see what functional, what group we have. So here is a methyl group, so I do have a methyl. So it's ready here, and it can be 2 in blue, or it can be 6 in green. And then it's this one. So I will circle the methyl, and this is you've probably seen this before. It's isopropyl, but I will still write the IUPAC name for this one. So why is 1 here is because if you start to number from the period, from this piece, it's 1, 2. And on carbon number 1 of this piece, it has a methyl, so 1 methyl ether. So this is whatever here. And it has a number of 3 or 5, which we don't know. Okay, and then is this triangle part. Oh, I'm trying to draw a triangle. Okay, that's the triangle part. The triangle part has the name of still the same. So number 1, 2. So on number 1, it has 2 bromo. So it's 1, 1 dibromo ethyl. Later on, we are going to put them in brackets. So all the stuff like this. And then whatever left is a methyl group, which is on, so that one is on 4 for both. And then another methyl group, which is on 3 or on 5 or on 3. So that's it. So what do I mean by you need to have the lowest position number? Is when you add all of them together. So this one gives you 14, and this one gives you 18. This one will. Does that make sense? Okay, so it is true for this problem that you are starting from the lowest, but it's not always the case. Okay, so I assuming you guys all know how to do nomenclature by using the rules and the tables. You are going to keep that table until 118C, so be nice to the table. And then what is R and S? So you can see like this, are they this, or are they this? It's something that you just need to follow the rules. And then, so you are start to learning something called chiral center. What chiral center means, it means the 4 bonds are different. So that's why you can see R and S here. It has 4 different bonds. And you are going to give them the highest one. Usually it's something like oxygen or nitrogen, because oxygen and nitrogen always have a higher rank than carbon. You can see from the table. But that's not something that's later on you will be familiar with. Usually the highest one, usually it's oxygen, nitrogen, or halogens, or something with double bond. So that's very common, so I would say. And then you rank the rest with the priority. That's the number 1 step. So rank the priority of that, and then put the lowest priority group to the back. So if I have the model with me, it's going to be something like this. So that's, if I have the hydrogen, like the hydrogen, I'm going to put the hydrogen as the back of the paper. It's like, if it's dashed, it's into the paper. So did you still remember from my first lecture, if it's dashed, it's into the paper. So I want the hydrogen to be into the paper. And looking the rest of the bond, like this. Then my 1, 2, 3 is definitely going to be 3 directions. And I want to count if they're clockwise or counterclockwise. So if it's clockwise, it's R. If it's counterclockwise, it's S. But you need to practice for a while to see it, but when you are naming, you have to put a R or S in front to indicate if that chiral center is R or S. That's why in my mind, nomenclature is not completed until you have identified all chiral center in that compound, and I lose a lot of points for that. So I spend many time to name it and then remember all those words for that compound, and I forgot to assign R and S, and I lose points for that. So let's practice on that, and we're going to talk about enantiomer afterwards. So on problem solving 4, you see there's only, the first question is circle all the chiral center. Because this one has 3 hydrogens, so it has the same compound. It's not chiral center. This one, carbon and nitrogen, is cyano group. 3 carbon are connected to nitrogen, so definitely this one is not, because it has the same sub. And then this carbon is, because one of them is a bunch of whole things. And then this is a methyl cyano, and there is a hydrogen. And then this one is also S, because those parts are not identical to this. It's not identical to this part. And it has a hydrogen, which didn't draw. So by following these rules, we can just circle all the carbon which is not bonded to the same stop. The common mistake I see in this part is there's symmetry in elements that actually you didn't see. So something like, if you are actually having a methyl group pointing up and a methyl group pointing down, and there is a, I will say maybe OH. So this carbon looks like it's a chiral center because, oh, you see this is not the same thing. But actually, it has a mirror. If you have a mirror in the front, there, although wedge and dash, they're not different. They're different, but it's still a methyl group. So this carbon is not a chiral center. So that's a very common mistake. Still the nomenclature nomenclature first. So if you finish, it's not that hard. I just put the name without R and S on this part. So the way we do it is whenever you have a ring in your compound, the ring always wins. So the longest chain should be this ring, and you can set this one as a stop. So this is 1 ethyl. Oh, there should be a dash. 1 dash ethyl. So 1 dash ethyl is this part. Because your alcohol group is also on carbon number 1, so there are 2 ways you do that, but I prefer to do this way, so I can know exactly where my OL is. In the future, you probably is going to see something like ENOL, which is double bond, and then you are going to put a number on EN as well, so that's maybe 3 EN1OL. So I prefer this way, so I can see clearly where my functional group is. But both ways are correct if you put the 1 to the front. And then the rest is not that hard. Okay, so this is not a name. Now let's start to identify R and S. I'm going to use a different color. You don't get confused with the number of my naming. For this one, so there are only 2 chiral centers in this compound, which is 2 green carbon. And then let's start to rank the priority. Bromo has a higher priority than chloro. That's how I remember it. It's at the corner of the periodic table. Those nitrogen, oxygen, fluora, chloro, bromo, they all have higher priority than carbon. That's something you can just keep in. Here comes to a important stuff that we're going to talk about is how to compare number 2 and number 4, because they are all carbon, and they're all 2 hydrogen bonded carbon, and this carbon is bonded to a carbon and a carbon. This carbon is also bonded to a carbon and another carbon. So by only comparing carbon number 2 and number 4, we cannot tell which side is the higher priority. And then we move on. When we move on, we are comparing carbon number 1 and number 5. Now we can tell because carbon number 1 is bonded to something with a higher priority than carbon number 5. It's only hydrogen. So this one wins. So this side is a higher priority, and this is the lowest one. So we just finished the first step, which is rank the priority for this one, and then put the lowest priority group to the back. Here, the lowest priority group is not in the back, it's in the paper, right? The solid line is in the paper. So what we do is we draw a small person here. So you are looking from this angle. When you are looking from this angle, this group is into the paper. And then you draw a dash to your chloro, and then you draw a wedge to your bromo. So think about you are looking at what this small person is looking for. It might take you some time to practice on that, but that's so there's okay. So yeah, so that's what I'm trying to do. You always put the lowest group at the back of the paper. And then if you think about that, just when you have a hand, so you, I will just draw it. So think about from that side from the angle of this person, the number 1 bromine is actually on your left, and then the chlorine is actually on your right, and this solid carbon is in downside.
because we do that a lot, so I can see it. So hopefully you can practice to see it. This is just put the lowest priority group to the back, and then assigning RS according to if it's counterclockwise, which is S, or clockwise, is R. So by doing this, we know it's clockwise because 1, 2, 3, and then this one is R. So this stereo center is R, and then because we know it's R, in the nomenclature, there should be a 3R here. This blue is dark. Okay. We're going to do this stereo center. This one, let's run to the priority again. Oxygen, which has the highest priority because the rest of them are all colored. What did I do? Anyway, there's only 5 minutes before we finish, so we just stop here.